to start in a little bit here, setting a little bit of a baseline. So when we're talking about security, well, why are we trying to do this? We're trying to make sure we hold on to the things that make us money. Whether that's minutes that we're terminating to somebody else's network, whether that's proprietary information or customer information that we have an obligation to keep secure. Time that we have to spend cleaning up on all these things, which it can be considerable, and the resources that it takes to recover from it, either in terms of either legal or time cleaning up, or the fact that the people that know how to clean up after it are also the same people that develop the applications. So you're not developing more applications to make more money. As an engineer, I think of security requirements as just being more requirements for what you need to do to build the system. And like I said, just a part of the everyday operations. Bob and Eric talked a little bit about different things that can be done. I think we're doing this a little bit in Jeopardy style, where you got some of the answers first, and I'm going to ask the questions later. So looking at the risks for what you need to protect, you need to see what's available in the systems that you have or what you're about to get. Because if you don't know what the risks are, well, then how do you know what you're trying to protect? So starting out with who's accessing the system, both taking control of the system and as a user, how do you know who they are? I think both of you also already mentioned the U.S. versus Pena case. The gentleman in Miami who terminated millions of minutes fraudulently. I think Eric mentioned, the authentication for that was very simple and easily guessed. And I have NPA NXX here. It should be, the full TN that was used for authentication. Clearly, that wasn't enough. There's different ways of doing authentication. For administrative access, of course, most experts in the field will tell you you want an encrypted session with strong authentication. You want centrally administered authentication. So, if Joe decides that, I'm not going to work here anymore, you can take him out of all the systems of the network at the same time. So what are these users allowed to do? Can they, as a client, can they make a call? Can they make international calls? Is that part of their plan? Have they paid their bill? Should they still be able to make that call? And how are these resources being used, and how do you know? That can be billing records, but that's also internal resources of, okay, so why is the load on my soft switch, racing up to 100%? Where is all this, where are all these resources being chewed up by? To a certain extent, these three bullets here, who is accessing the system, what they're doing, and how are they being used. And this is the AAA authentication, authorization, and accounting. But it's also instrumenting the network and seeing where things are being used. The next tough question is, how vulnerable is your system to attack? And here's where you really need to look into the system architecture, work with your vendors, work with experts in the field. Reading the documentation and looking at the system is one part, but you've really got to test it too. I mean, vendors aren't going to intentionally sell you something that's insecure. Well, maybe they would, but they wouldn't admit to it unless you ask the right questions. So just in terms of voice over IP, I have some example questions here. Are they blocking road media at the edge? If they get it, how many resources does that use up? Is that actually using a license? How is malformed signaling handled? Are they just passing it on to an internal element if you're looking at the border? And again, you can't just apply this at the border of your network. You have to apply it to every element in the network, to the network itself, and to your internal policies too. Looking at, so one of the things that has been a problem in a couple of networks I've worked on is, capacity constraints and denial of service. One of the worst things that can happen is that somebody, either intentionally or unintentionally, maliciously, or just because they're trying to use the service they paid for, makes it so the system is unavailable in some way. And whether it's good traffic or bad traffic, too much traffic that takes down your system is still too much traffic. So you need to be able to set limits on where that traffic comes in, how much, how frequently. And you do need to understand who your customers are, different customers are going to have different requirements, different types of traffic. You know, a customer who's doing bulk credit card authorizations with 6-second calls, you know, they might say, oh, you know, we're going to do 10 million minutes of traffic. If that's 6-second calls, that's a lot more traffic than a customer who has 3-minute calls, which is a lot more resources on the signaling side. So again, understanding your customers, understanding where the pain points are going to be. You know, I've seen different customer sets having different, you know, peak days in the network. You know, people talk about the day after Thanksgiving being the busiest day of the year for shopping, well, also for credit card authorizations. On the residential side, you know, Mother's Day being the busiest day on the network, and maybe that's true for the PSTN still, but maybe not. For IVR folks, we see a lot of traffic on the day before Election Day doing all that get out the vote calling and that sort of thing. And, you know, there's still going to be schoolyard behavior too, where, you know, Johnny gets mad at Fred because Fred said something about him, so, you know, he'll figure out how to take the network down and in some way deny service to Fred.